Hi everyone. This is from the Tuesday-Thursday notes. We just started Unit 3. We just finished up Units 1 and 2. And we talked about like 3 major things today. So let me start here. We talked about online privacy security. You know, I prefer students to use online rather than say they got stuff from the internet. Even though the world calls it the internet, more technically it's online. And so if you were to look at the internet, you know, the internet's this cloud that allows us to communicate to all these different web presence out there. Tons of them. Nobody knows how many actually. Okay, so we prefer online, and what they were to do was to comment on privacy and security. This was at the end of Unit 2, and they needed to do it in the discussion forum. So I looked through those, and what we want to talk about a little bit today is people's perception and reality. So here's what we did. I gave some examples. For example, people say employers can hack in and look at your Facebook accounts. I don't know if that's true or not. I would assume not. Somebody made the comment their employer knew what they posted on Facebook and they don't have access to their Facebook. Well, I assume if you use Facebook, some type of social engineering, and not engineering, networking, social networking, that you have at least more than 2 or 3 friends. Okay, so let's say you have only 5 friends. But you post something and one of them 5 friends take it and post it to theirs, and they have maybe 5 friends, and those 5 friends post it. And so you could take something that you put on Facebook, thinking not very many people can see it, and 2 or 3 hours later there can be literally thousands. And somewhere somebody would look at that and say, hey, they're saying this about work. And so they talk to your employer. Your employer now knows a few hours later what you posted on Facebook. All right. So what we did, we divide the students, got in some groups, and they talked about there's places people have information, and this is just a start, where you have to give it to them. Your employer is going to require to have your Social Security number in order for them to do payroll. Okay, and probably other pieces of information about you. Or if you're applying for a job, they're going to have you apply online. So that information's online. You join certain memberships to certain groups require you to belong online. Not just fill out a piece of paper, but online. All financial things, excuse me, whether you're dealing with your retirement, stocks, bonds, or even simple things like banks, credit cards, all that stuff, all your financial stuff, it's hard to work with any of that and not have some online presence. It's possible, okay, I'm sure there's people who they use strictly cash. They don't have any checking account, they have any money in the bank, they just live on cash. There's probably more than I care to even think about, especially like homeless people and so forth. But basically, a lot of people need to do financial things. Your credit ratings, you don't have much, you know, that's going to be on there. If you're going to buy anything online, that was one we listed over here. They said you don't have to do that. You could probably live and never buy online. If you have any type of insurance, they have information about you, and then the IRS and the whole government in general requires us to give them a certain amount of information. NIACC asks for certain information of their students. Okay? Some places you can probably avoid membership to certain things, just don't join. Social networking, I don't know of anybody who has been held hostage until they signed up for Facebook or started tweeting. Online shopping, you make a decision. Maybe you just don't want to do that. Some people do that. They talk about PayPal or methods of doing that. So I think it's important, and we're going to talk way more about this when we get to the security items after the networking, which comes right after midterm. And we'll discuss that more. All right. Over here, I'm just going to highlight a couple things here, and this actually goes to the next picture, and I can just do that right now. I'll move. What we want to understand, and then I'm going to cover a few details in the last picture. What we want to understand is this, and I'm going to pick another color here. All right. What we want to understand is this: software or programs, okay? Programs, software, we have that like on our hard drive. I'll make the line a little bigger. We have this on our hard drive. Software is loaded in the memory. For example, the operating system would be loaded in there first, and then other software programs are going to use up some memory. From memory that's taken up, it's processed in the processor, sent back to memory. Now, where does it go in the processor? It goes into registers. These are not this. Don't confuse this with the registry that Windows uses. These are registers. They're storage areas in the processor. Very fast, and the processor manipulates things based on that. Your processor can have a word length of 64 bits, which would be probably something current. A little bit older computer might be 32-bit, and maybe back in the old days a 4-bit, and everything in between. Okay, so the information has to go in the memory, and then from memory the instructions would pull up what it needs to the processor. The processor will do one of two basic things. It'll make an arithmetic decision or a logic decision. It can do arithmetic, that's why it's called an ALU, arithmetic logic unit. So it can take a group of bits and decide if they're bigger or smaller than another, and then make some action like move something on the screen or do something, calculate something or whatever. Arithmetic, add, multiply, divide, subtract, and then raise the powers, and all the things mathematically we have calculators do, a computer can do. And that's it. This part sometimes people struggle with, and just do that. So we have instructions come up and come back. As we load software, we start to use up memory. Okay? So then, this isn't a new idea. It's actually an old idea. They created virtual memory. They said, well, let's use a place on the hard drive, okay, and store things there and let the computer think that's memory. So we keep stuff here we don't use very often, and then we can bring it into memory when we need it and throw something out. There's one issue. The speed here is in milliseconds. Speeds in here are like nanoseconds. Maybe not exactly, but pretty close. So this is like a turtle, and this is like a jet airplane. So when the computer needs to get things off the hard drive in order to function, it's going to slow down. It depends on so many other things, but it will slow down, because getting stuff from the hard drive is way slower than moving things around in there on the motherboard. So that's our lesson here. Now, how fast can the computer move stuff through? Well, the way it's kept track of is by clock cycles. It takes so many clock cycles to move something to here, to process it and send it back. Maybe 8 clock cycles or whatever. So everything inside the computer is done by timing. Okay? You're going to use so many clock cycles to get this done, so many to send it back. Operating system can manage that. So we have in computers clock speed. I just made up one, 2.5 gigahertz. I think the machines in our lab, PC229, they might be, I believe, 3.4. But anyhow, the bigger the number here, the faster. Now you got to be careful. If you're buying a computer, you might think, well, I'm going to buy the fastest processor I can get. If you can't keep the processor busy, it won't do you any good. Okay, more or less, if you don't have enough memory and the computer needs to resort to going back and forth to the hard drive, it's just that's going to be irrelevant. So we're gonna look more at that as we move along. Okay, so that's talking about performance. We're going to review that on Thursday. And the last thing, we're not going to spend much time on this. I want people to understand where numbers like 32 bits, I'm over here on the left, if you're looking at the screen, where that number came from. Okay, where it came from. So this is a little review of your elementary math. Some ways or another they taught you we use the decimal system, base 10, and we have 10 to the 0, which is 1. We have 10 to the first, which is 10. We have 10 to the second, which is 100. 10 to the third, 1,000. 10 to the fourth, and so forth. So here, when we have a number like 1,000, this is 1,247. One group of 1,000, two groups of 100, four groups of 10, and 7 groups of 1. Computers, we use a different color. For example, computers use base 2. So they only use the digits 0 and 1, whereas base 10 uses 10 digits, 0 through 9. So base 2, these are 2's here instead of base 10, those are 10's. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth, 16, that's a 16, then we have 32, 64, 128. So we may have, using the ASCII code, a capital A is a 0, 1, 0, 0, 0, 0, 0, 1, I believe. If we were to convert this to base 10, we got one group of 64 and one group of 1. That's how I got 65. We do not need to do that in this class. The main emphasis is to understand where these numbers come from, like 32-bit or 64K. Let's say you found an old flash drive laying around and it said it's 64 kilobytes. Well, some people say K is 1,000. Not exactly. It's 2 to the 10 or 1,024. So when we see numbers like it's so many gigabytes or so many million megabytes or terabytes, okay, and you say, well, isn't this supposed to be 1,000? Well, it's not exactly 1,000. Isn't this supposed to be 1,000,000? It's not exactly 1,000,000 because everything's on base 2. Okay? That's why the word length is nowadays 64 bits because everything is base 2 in the computer. All right. Where is that used? We did a little example in class. We looked to download some software. It's called Wireshark, and it gave us the options to download the 32-bit version, the 32-bit, or the 64-bit version, and it gave us a couple different operating systems to download it to, or it let us download the open source. And we'll talk more about that later on. So that's it. That's the review for Tuesday, 9/24. And a week from today, we have skills based on word processing. We did a group project in class today. That's it.